Hydraulics are very interesting to actually recreate. They're not very hard to recreate, but in real life, how it actually works is that you have a shallow tube and you have a full tubes, and they're sealed in a way that there's no air coming in and out. And then you have a tube that feeds in the shallow part a liquid. So that's why it's called hydraulics. So when you're pushing in liquids, it's actually building pressure in the tubes and pushing on the piston. So it pushes the piston up and it makes it very strong. Now to make the pistons retract, it simply retracts the fluid from inside and the pressure takes care of pulling it back. Now in 3D, it doesn't work that way because we simply fake it by pointing one bone at another bone. And that way you make sure that they actually point at each other. So to follow along, you can open 19 hydraulics_start.blend and then you'll be presented with these two awesome hydraulic pistons that Gleb actually modeled. So from there, you choose whichever one you want to actually follow the lesson with. I think I'm going to choose the smaller one. All right, so we're going to basically select this, and sorry Gleb, let's delete that. And I'm going to grab this one and let's actually prep the model. As you can see, it's not centered and the pivot points are a little bit all over the place and most of the transform are not cleared. So it's a very important step to actually do. So let's go to the wireframe mode, make sure that you have X-ray on, and let's try to recenter the model directly in the scene. All right, so that should be good for this axis. So let's go to the side view and let's do the same thing. So let's try to align the center there. It's good to be precise. All right, so there you go. So now we need to freeze these transform. And to do that, we go to Object, Apply, or use the shortcut Control A, and then choose All Transform. So now all the pivot points are there, all the objects are transformed scale 0. So now they face all the same direction of the bones, and they will be start at the same point of the bone, I should say. All right, so we do need to do a bit more prep work here. As you can see, these two are together. So let's actually separate them up. So I'm going to go back to the wireframe mode. I'm going to select a part there and then press Control L to select that part. And I'm going to press P and part deselection so it's its own object. And I'm also going to go into edit mode, grab the row of edge at the bottom and do G and then Z to bring them down. So we have some cylinders inside. All right. Now we're ready to actually start rigging this. All right, so let's actually add an armature. So Shift A, add an armature, and right away let's actually go switch that in the viewport display to a bendy bone, and let's set it to in front with names and axis on. All right, so let's also make sure that lock object mode is off under edit, and let's also switch this to active element so we can actually quickly scale that down. So enter edit mode before scaling down, select the bone and then scale it down. And let's make it skinnier with Control Alt S. Something like that should do the trick. And let's zoom in a little bit closer. I just simply press the dot on the numpad and it zoom or frame to the selection. So I'm going to go to the side view and I'm going to continue scaling it down until the joint sort of fills that screw right there. All right, so I'm going to grab the end there and I'm simply going to extrude in the Z axis up until the end of that tube there. So now I can get away by just selecting these two bones, switching this to median point, do Shift D to duplicate them, do rotate 180 degree, and then grab, so G, and then Z, then bring that up. And again, you can try to actually go into wireframe view and sort of align these two, right? So G and then Z, well, let's align these two, and that should do the trick. All right, so let's also make these two top one a little bit skinnier. So Control Alt S, so we know which one is pointing at which one. All right, so now we have pretty much our bones set up. I'm not going to bother renaming them for this. We're just basically going to make a quick example of how this actually works. So now what we need to do is we need to go into pose mode and let's actually take the armature out of the hydraulics collection. Let's dog that down and make it unselectable while we actually work at the armature. All right, so right away, if I switch this on, we notice with this type of hydraulics that they should only bend in one way. So we're going to rectify that, and we're going to make sure that we lock the x-axis as well as these two rotations, so the Y and the Z for that bone, and it's in local mode. So Y and Z, and then we don't need the scale for this. Now this should only rotate in X, so we can lock these, and lock these. And we're going to do the same thing on top here. So I'm actually going to lock the Z axis for this one. And for the rotation axis, it's the Z that it's taking in consideration here. So we're going to take off X and Y, and then we don't need this either. And then for this one, it only rotates in Z. So we're going to take off everything else. All right. So these are basically the locks that we assign to that. So they move. So usually you would have this part connected onto a part of a mechanical arm and then this part into another one, and they won't necessarily twist, so they will be linear, if you will. So make sure to lock the right axis for the linearity of your own hydraulics. All right, so now what we can do is we need to get this bone pointed at this and this bone pointed at this one, and we do that using constraint. So if you go to the constraint and you go here, we can use a lock track. A lock track constraint will lock only the needed axis and not use the other rotations. And this is local only as well. So in this case, we will use X because we only want the X to rotate at the root. Then we want the Y axis to point at the target. So if I go here, choose armature. Now you could point this one at that bone and that bone to this one. The problem with that is that you will end up with a dependency issue because they're both using a constraint that is pointing at each other. So instead, you point at the target bone that it's parented to. So this little one here and this little one. So I'm going to focus this one to this one, which is called bone 002. And then I'm going to do the same thing here and grab this one, use a lock track, and this time we're going to lock the Z and point in Y, and we're going to use the armature, and then we're going to use bone. All right, so now if I do this, it actually works, but it's pointing at the base of each bone and not at the tip. So in order to rectify that, simply select the bone, and where it says head tail, you simply push that all the way to 1. So now we have proper hydraulics. All right, so now all we have to do is simply bind the mesh to that. So let's select the screw. First, let's make sure it's selectable. So let's select the screw. Let's select these two parts. And then shift select that bone, Control P, bone. And then let's select this part here. Select this bone, Control P, choose bone. Let's select that there and that nut right there. And this tube, shift select this bone. All right, and Control P, choose bone. And let's do the same thing at the bottom here. Just try to select all of that. Select that bone, Control P, parent that to bone. So now if I do a bit of cleanup and I move these to a different layer and grab this, we have hydraulics. All right, very simple. So now to finish this off, let's actually add a CBS collection. And let's add the ever so famous circle. So rotate X 90 degrees so it points at the same space than the bone. And then let's go here, the viewport display, and let's choose the circle for both. And then from there we can hide the CBS and we have a final piston. Now we can also from there actually go hide the name and axis, and then from there we have a finished pistons. Now you could limit where these go, but usually you'd know as an animator where to stop. All right, so we do have a single hydraulic piston motion.